The complex number system, which is what we actually live in. Today is 9, 10, 19. All right, ladies and gentlemen, I introduced you to the complex number I yesterday. What is I equivalent to? Square root of -1. And then if we square both sides, what is I squared equivalent to? -1. You square both sides, the radical cancel out, which is kind of weird, and I don't know that I trust that, but we're going to go with it. Okay. And because we know that now, we can actually solve these equations, which we couldn't do before. So if I wanted to solve x squared equals -25, I could take a square root of both sides. Don't forget the plus or minus, because there's always two answers. How does the square root of -25 simplify? So I'm hearing square root of -1 times the square root of 25. And so that would turn into... Thank you. I think I'm getting sick. This is awful. The last time I got sick, I had pneumonia. Can you remember that? Yeah. Huh. God. No, that was one. This is 2 years ago that I got pneumonia. Last year I was on. Right. All right. What can I do on this one here? Subtract 36. Okay. We'll do more of this, by the way, if you're like, what? And then I can take a square root of both sides. The square root and the square cancel out. Don't forget the plus or minus. And how does the square root of -36 clean up? Yeah, plus or minus 6i. Very good. So before we couldn't solve those because they didn't have any real solutions, but now they have imaginary solutions. So we can pretend that it works. That was my joke for the day. I don't understand what the point of it is, though. So when we start graphing, we can see real solutions. We can't actually see the imaginary ones, but they are there. Algebraically, they work, but actually in real life, they don't. It's interesting. At the U of A, which is really interesting when I taught at the U of A, they, in college algebra, which is the class you guys are in, there's no imaginary solutions. It's like we don't even talk about it. They do not. It's like Fight Club. We just don't talk about it. I always thought that was interesting. We assume they know, but we never talked about it. All right, example 1. Find each product. Express the answers in standard form. Again, standard form for a complex number is a plus bi, where we've got the real part and then the imaginary part hooked on the end there. So product means multiply, so we're multiplying. It's more easy stuff today. This is a great section to end in.
Does this mean that if we did it with that I squared, that'd just be a negative whatever?
All right, so we've got 2 plus 3i times 4 plus 5i, and we are going to multiply. So I'm going to multiply, distribute in our 2 here. 2 times 4 gives us 8. And then 2 times 5i. 10 i's. And then we're also going to distribute in the 3i. So we have 3i times 4 is going to give you 12 i's. And then 3i times 5i would be 15i squared. Very good. So now is the cleanup portion of the program. We're going to add some like terms together. So I have 8. What's 10 i's and 12 i's? 22 i's. But then we also have more cleanup here. I squared. What is I squared? -1. And so this is really 15 times -1. And what is 15 times -1? -15. So we have 8 minus 15, which is -7. Very good. Plus 22i. So here is the A and here is the B. the real part. Here's the imaginary part. That is our answer. What do we have to do for letter B? 1 minus 7i quantity squared. Write it out 2 times. Oops. That would be always my recommendation, but maybe you know the pattern. And if you know the pattern, that's lovely. And I'm always going to write it out. And we can multiply. First times first is 1. And then 1 times negative 7i. Negative 7i. Distributing my negative 7i. Negative 7i times 1. Negative 7i. And then negative 7i times negative 7i. How's it? 49i squared. Very good. And what do we know about I squared? It's really negative 1. So we have to clean that up. Oh, yeah, thanks. 49. All right, so we have 1, and then I can combine my i's to be negative 14 i's, and 49i squared turns into negative 49. Can you do that in your head? Maybe. Yeah. So negative 48 and negative 14i. Yeah? Easy or hard? Easy. Okay. Any questions on those 2? Nope. All right. Find each quotient. Product quotient. Kind of, yeah. I mean, so remember what we're doing is, to find the quotient is we're actually, remember I is defined as the square root of negative 1. So actually right now what we're looking at, we have a radical in the denominator. And so in order to find the quotient, we actually are going to be rationalizing. Okay, so if you'll remember, we want to actually multiply by the conjugate. What would be the conjugate? 5 minus 2i on top and bottom. So we're going to multiply by the conjugate. Multiplying by the conjugate is a strategy we use in calculus a lot. Sir. I'm sorry, say again. Zoom. Oh, Zoom. I'm sorry, yes. I heard Zoomalope, and I was like, what kind of animal is that? Okay. There we go. All right. All right, so we are going to multiply by the conjugate. The conjugate changes the sign, and that'll help us clean this up really nicely. We're going to go ahead and distribute in the numerator for this one. 3i times 5 is going to give me 15i. And then 3i times negative 2i is? Good. Yes. Eric, what you said is correct. I'm going to do it later. All right. On the bottom, what do we have to do downstairs? Distribute. So we've got 5 times 5 is 25. Outside, we get negative 10i. Inside, we get, and then last times last, 2i times negative 2i. Negative 4i squared. Very good. So again, remember, when we're using a conjugate, and this is what, for some reason, my pre-cal kids just cannot figure it out. I don't understand, and I do so many of these. They all put the conjugate on there, but then they just like cross it out. They're like, it goes away. And I'm like, no. It doesn't just go away. the middle terms combine to be 0. But there's still stuff left on the bottom. And they just, oh my God, they've got like rocks in their head. I don't know. Okay, so here we go. What happens with the I squared? It's -1. And so this becomes 15I plus 6. And in the denominator, again, that I squared is really -1. So we have 25 plus 4. And 25 plus 4 is 29. So this is a very good answer. They want it in standard form, which means we want to divide and conquer. What is 29 dividing? Just the 59? And the 6. Very good. So we separate 15 over 29I plus 6 over 29. So that 29 divides both terms. So we need to separate it if we want to be in standard form. It does say that in the directions. Jack.
So it doesn't matter if it's like 6 over 29.
It doesn't say it again. It doesn't matter if it's 6 over 29. Oh. Thank you. Jack says it should technically be, and Jack is totally correct here, 15 over 29I. There we go. Thank you. Why is this better?
Because they're not supposed to have I.
Yeah, A plus B. That's technically, okay. They're totally equivalent, right? They're identical to one another. But yeah, thank you, Jack. That's absolutely correct. Okay. I am telling you on these to look at page 87 for one more example. Would be a good idea to have a look at that. All right, what do we need to do for letter B here? Multiply by the conjugate. What is the conjugate? 4 plus 7I. Very good. Do I need to do this, or can I let you guys work it out? All right, you all do it. You're all working hard on it already, so you go ahead and do it. Yeah, you do. You have to distribute on top and bottom. I don't know, because it's supposed to be 29. Sorry. Thank you. Oh, man. Okay. Those go away. I need help. What's 16 and 49?
Why do you want us to split it?
These are technically equivalent. To be in standard form, it says express the answers in standard form, then we should see the real part and the imaginary part. That's the only reason. Oh, did I make another mistake, or am I good? Is that right? Okay. Do you guys have any questions for me? Wasn't that fantastic? Do I have any more? No, I'm done. Is it 65? Why is it 65? 16 plus 49. Yeah, the I squared is a -1, so change to positive. All right, ladies and gentlemen, thank you very much. Go ahead and do 28.